Hello everyone, Miss Hanley here, and we're now going to start talking about multiplying bigger polynomials. So rather than a monomial times a polynomial, your learning target for today is I can multiply a binomial by a binomial, or it's what we call foiling. So people can also say I can FOIL, that might be your learning target. So FOIL stands for the way that we multiply a binomial times a binomial. Each letter of the word FOIL is going to tell us what to do. So we want to look at our steps here, and then as we fill in our steps, we're also going to do one of the examples below. Alright, so if you look at your example, example 1, we have x plus 1 times x minus 7. So they're both binomials because they have two terms. So when you have a 2 by 2, we want to multiply that together by foiling. You don't necessarily have to FOIL, although it helps you remember not to forget. That's silly. It helps you not to forget any terms when you're multiplying. So just keep it in mind that it's a good trick, and it will make sure that you always multiply everything that you need to. Okay, so the first thing that we're going to do is multiply the first two terms in each set of parentheses. So we're going to take x times x, and that is your f in FOIL. So for first, we're multiplying the first. We're multiplying the first two terms. Multiply the first terms in each set of parentheses. Okay, and so down below when we do that, we have x times x, which is going to give me x to the second. Alright. Next, we want to use the O for outside. So you're multiplying the two terms that are on the outside of the both sets of parentheses. So in this case, it would be x times negative 7. So multiply terms on the furthest left and the furthest right, or on the outsides of the parentheses. So we would have x times negative 7 or negative 7x. So that's your O. Okay. Next, we're going to get to the I, which is for inside. And as you might imagine, those are the two terms that are going to be on the inside of the parentheses. So we want to multiply terms on the inside of both parentheses. And so 1 times x is just going to give me 1x. And then finally, we're going to do the last two terms, so that's our L. We'll multiply the last two terms in each set of parentheses. And that is foiling. Okay, so we ended up with x squared minus 7x plus 1x, and then when you do 1 times negative 7, that gives us a constant of negative 7. Alright, so let's go ahead and look at the last step here, CLT and SF. So that stands for combined like terms and standard form. Combined like terms, which we're used to. You should always be able to combine your outside and your inside steps. Not always, but most of the time. And then you want to make sure that it is in standard form to help you out. Okay. Later, when we use these to actually graph quadratics, it will be very helpful if it's in standard form. So last step is just combining like terms. I see a negative 7x and a plus 1x are the only like terms I have. So I'm going to bring down my x squared. Then I have negative 7 plus 1 is negative 6x minus 7. So there, we've just FOILed. Alright, so let's see if we can try that with our second example. So we're going to go first, so the first two terms in each set of parentheses. So we have 2m times m, which is 2m to the second. Outside, or outer, some people say, is going to be 2m times 9, so 18m. Inner, or inside, is going to be 5 times m, or 5m. And last is going to be 5 times 9, or 45. Then again, combine like terms. So we get 2m squared plus 23m, 18 and 5 are my like terms, plus 45. Alright. And then there's a couple special cases. So we call these square of a sum or square of a difference. And that's when you're taking a binomial and you're squaring it. Okay, so if you look at our example below, x plus 9 in parentheses squared, you're taking that binomial and squaring it. And in this situation, there's nothing to FOIL here, right? You don't see anything to FOIL. But think about when we square something, like if I had an x squared, that is x times x, right? Or if you have 5 squared, that is 5 times 5. So when we have a binomial squared, just as we would an x squared or a 5 squared, it's that thing times itself. So it's going to be a binomial times binomial, which is how we end up with FOILing. All right. So your first step is going to be to sort of write it out. Okay, so we're going to get rid of the square, and we're actually going to write it twice. Okay, so I'm crossing out the x squared, and we're going to say this is x plus 9 times x plus 9. And I guess you don't have to cross out the little squared, but if you have more space, you could write it right next to it. Normally I cross out the squared and then I just put another set of parentheses right next to it, which is why I did that. But my handwriting is very little. Alright, so now it's a binomial times a binomial, so we would have to FOIL. So we're going to take the same steps that we were doing before. We have first x times x, which would be x squared. And then we want to do outer. So we have plus 9x. Then we want to do insides, which happens to be the same number, plus 9x. And then we want to do last, or plus 9 times 9, which is 81. So we get x squared plus 18x plus 81 when we combine like terms. And now that is in standard form. So your step 2 is to FOIL. First, outside, inside, last. And step 3, combine like terms. And standard form. Okay. So let's look at our second example over here. Again, we want to write it twice because that helps us remember to FOIL. So I'm going to get rid of the square and put another set of parentheses with the same thing, 2x minus 3. Okay. And then it's a matter of step 2, which is to FOIL. So first gives me 2x times 2x, or 4x squared. Outside gives me 2x times negative 3, or negative 6x. Inside gives me negative 6x. And last gives me plus 9. So 4x squared minus 12x plus 9. That would be my answer all FOILed out. Some of you guys might be recognizing a few things. Okay, so there are actually some shortcuts to doing these. If you look at our first example, the first term is x squared, and x was the first term in our binomial. Right, so we squared that first term. The last term, 81, is 9 squared, okay? And then the middle term is 9 times 2 times x, or 18x. On the other side, we actually end up with the same thing, okay? We squared 2x and we get 4x squared. 2 squared is 4, x squared is x squared. Then we squared negative 3 and we get positive 9. And then lastly, we did 2 times 3, or negative 3, times 2x. So 6 times 2x is 12x, and take the sign, which is minus 12x, which is what you get in the middle. Oops, sorry. So to generalize, when you have a sum of a square, or the sum of a difference, we can come up with a shortcut. And that shortcut is you square the first term, so you would have a squared. You're going to square the last term, so b squared. And the middle is your exponent, 2, times the first term times the last term. So 2 times a times b. And this will work every time. If you would rather use the shortcut, then you won't have to write it out twice in FOIL. You can just remember the shortcut. So let's just do a quick one to show how it works. So 3x minus 5 squared. So to get my first term, I'm going to square 3x. So I get 3x times 3x, which is 9x squared. To square the last term, it would be 5 squared, or negative 5 squared, which is 25. And then to get your middle term, it's 2 times 5 times 3x. So 2 times 5, negative is negative 10, times 3x is negative 30x. Alright, this is your answer that's in standard form already, and it's already simplified. If you had written it out and FOILed, right, these two things are equivalent, you're going to get the same answer. First is 9x squared. Outside is negative 15x. Inside is negative 15x. And last is plus 25. So we end up with 9x squared minus 30x plus 25. So whether you use the shortcut on the left or you write it out in FOIL, you should end up with the exact same answer every time.